121 task scheduler from LeetCode. A characters array task representing the task a CPU needs to do, and a non-negative integer n represent the cooldown period between two same tasks are given. Return the least number of units of times that CPU will take to finish all the given tasks. So let's do the first example to understand the question. A list of tasks are given and a cooldown period between two same tasks. So the cooldown period only applies if the CPU is doing two same tasks. So let's ask CPU to iterate over these tasks and see what happens. So the CPU starts from the first task, which is task A. It does the task A, and it goes for the second task. Second task is similar, same as the previous task. So the CPU is going to have a cooldown period before doing that task. And it goes to the third task, which is similar to the previous one. So it's going to have a cooldown period before doing that. And it goes for the first task, which is not similar to the previous one. So there is no cooldown period. It does it right away. And for the fifth task, there is a similar task as the previous one. So it's going to have a cooldown period and so on. And as you see, it will take 14 units of time to get this done. How can we make this efficient? As you can see, if we have if we don't have similar tasks, there is no cooldown period. We can use this property, this information, to solve this problem efficiently. How? As you see, we have task A, and after task A, task B can happen right away, and there is no cooldown period. And the cooldown period for task B is 2 as well. So we can have task B here, and again the cooldown period is 2. And as you see here, instead of doing it in 14 units, this can be done in 8 units by using the property that the different tasks can happen after each other and there is no cooldown period. Let's go through the second example. In the second example, as you see, the cooldown period is 0. So the task, even if they are similar or they are not similar, they can happen after each other. So it does say task A and then another A and B and so on. So the cooldown period is equal to the length of the tasks. So by using this information that we have gathered from these examples, we can implement our coding. So let's go through the code. For solving this problem, we are going to break this problem in 2 different categories. The first category is like when n is equal to 0, and if n is equal to 0, it means it's this case that we don't have any have to have a cooldown period between tasks, even if they are not, if they are similar or if they are not similar. So in that case, the length of the unit is going to be equal to the length of the task. And the second case is when n is not equal to 0. And for that case, we need to find out how many cooldown periods that we are going to have. So in this part of the code, we are going to calculate how many cooldown periods that we need for this example, which we are going through this and this example. And then we are going to sum that up with the length of the task and return as the result. Let's go through this example and see how we can do that. First thing that we are going to do, we are going to make a hash map of this list and see how many of each unique tasks that we have. As you see, after making this hash map, you see we have 6 of task A, 2 of task B, and 1 of task C, D, E, F, and G. So how can we use this information to solve this problem? We can get the values of every single of these tasks and make a list from it, and then sort that from the smallest to the biggest one. So what is the benefit of that? We know that the biggest number that we have here is the maximum number of idle time or cooldown time that we need. Because if they are not similar, we don't need to have a interval unit. The when complication comes when we have similar tasks. So if these are like, if it was just like C, B, D, and every one of these tasks it was just one, we didn't need to deal with cooldown period at all. So the complication comes when we have like couple of similar tasks. That's why we sort it and we use the maximum number, which is the last one, which is -1, as the base case. And we are going to, what we are going to do, see at this line we are going to make a hash map. At this line we are going to get the values as a list and sort them to be able to get the last one, which is -1, as the base case and base case. And then we are going to call it like idle time, and we are going to multiply that to n, because based on the number of repeated like tasks that we have, we are going to have that amount of idle times. So we have 6 A's here, so it's 1 2 3 4 5 6 A's. So here we can get rid of this column. So we have 6 A's here, 1 2 3 4 5 6, and we don't need these two, the last two, because it's done. If it is done, we don't need to have an idle time, we don't need to have a cooldown time, so we are going to get rid of these two. So that's why we are going to say frequency is -1, which is 6 minus 1. So the number that we get from here is going to be 5. So 2 multiply 5 is going to be 10. So let's see, based on the illustration that we have here, it's the same number that we see from here. So we have 2, we have 4, we have 6, we have 8, and we have 10 cooldown period for the max one, and that's correct. So, and we have 10 cooldown period, and what we need to do, we need to fill these gaps with the other tasks that we have. This way we can have an efficient like CPU operation. And for doing that, we are going to start to iterate over this list from index 0 till the end, but we can avoid this because we have already used that to consider the amount of cool time period that we need. So we go all the way till here, right? So let's start iterating over and fill these gaps. So we start from the first one. So we get the minimum of the number 5 that we have here, right? It's 6 minus 1 is 5, and the frequency is 1. What is the minimum? It's 1. So what we are going to do, we are going to add G here, right? And we go for the second one. It is another one. What is the minimum of 5 and 1? It's 1. So what we are going to do, we can add F here. And we go for the third one. Minus minimum of 5 and 1, it's 1, which is going to be E here. As you see, because they are not repeated, so we don't need to have any cooldown period. And for the fourth one, it's 1. What is the minimum of 5 and 1? It's gonna be D here. And for the fifth one, what is the minimum of 5 and 1? It's 1. So now it's going to be C here. And now it's 2. And what is minimum of 5 and 2? It's 2. Now it's going to be B here. It can be 1B here. And we can put, because there should be an interval period between this B and the other B can be here. So as you see here, we are going to have 1, we're going to have 2, we're going to have 3 cooldown period left, plus the length of the task, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, which is equal to 13, is going to be 16, as you see here. And the time complexity for this case is on, because we iterate over every single item of the list. And the space complexity is on as well, because of the hash map that we have here. And thank you.